in this part of our video, we will be looking at some basic programs and we will be talking about their complexities. So this is the code snippet 1 where you have a for loop and there is a constant time operations. It is order of n because the loop, outer loop is running n times. But if I am talking about theta notation, we cannot say what is the complexity in terms of theta. Why? Because if I am talking about theta needs to be exact. We cannot say that the loop is for sure running for n times. Let's say the statement written inside this for loop is system.exit 1. Okay, so I'm not even going into the for loop second time, I'm just going into the loop and exiting from that, right? So in that case, theta should not be n, theta should be 1, right? Because the loop is not going on for n times. So that's why for theta we have to go inside the block, but whenever it comes to big O, you can just give the maximum complexity of a program, which is in this case it will be order of n. Okay, so now let's talk about code snippet number 2. Whenever you have for loop inside the for loop, then in that case there are two ways to calculate it. First way is check how many times the outer loop is running, check how many times the inner loop is running, and do the multiplication, or do addition for all the times the inner loop is running. So right now outer loop is running for n times, inner loop is running for m times, and internally we have some constant time operations, so we are not considering it. So it will be order of n into m, right? Now the code snippet number 3 says there are two for loops, one for loop which is going from 1 to n and the second which is going from 1 to m. These for loops are not in between, so the point is these will not get multiplied, but this will get added. Okay, so the complexity for this program will be order of n plus order of m, because the first loop is running for n times and the second one is m. They are not into each other, so the complexities will be order of n plus order of m. Okay, now this is the third one where you have to tell me the complexities. Okay, for loop is there and the for loop is going from I equals to 1 to I less than n, and I becomes I into c, and inside this loop there is a constant operation going on. So what I'll do, I'll just copy this and write it down here so that I can explain you this in a better way. So first of all, I'll suggest you to pause the video and try to do it by yourself. Once you are done with your complexity, then only look into the video. Okay, so now if I'll talk about I, so initially the I is equals to 1, right? I am assuming that is equal, C is 2 and n is a bigger number, okay, so that we are not coming out of the loop very easily. Okay, so let's say now I is 1 for the first time, right? And whenever the second time is going on, I becomes I which is 1 into C which is 2 in our case. So second time I will be 2. At the third time I will be 2, which is I right now, I into C. So now I is 2 and C is also 2. So I will become 4. Now in the third time, what will be the I? I is already 4, right? 4 is I into C is 2. So it will become 8, right? And in the next time I will become 8 star 2, right? Which is 16. And after that I will become 16 into 2. So if you will observe this, what is going on? This is 2 to the power 1, 2 to the power 2, 3, 4, 5, right? So it is going, and the first one which is 1 equals to I 2 to the power 0, right? We can say 2 to the power 0 to 1. So the point is I is raising by 2 to the power k, right? So can I say it is 2 to the power k? The loop will be going on till this value is less than n, right? If I take log on both sides, so can I say this all will be constant, k log 2, and this will be less than equals to log n. So can I say this is nothing but the complexity will be log n only, right? So that's how the complexity will come out to be the log n. Okay, I hope this is clear. Now let's come back to code snippet number 5. I'll just copy this code in order to understand it in detail. So I am assuming C equals to 2, okay, and n, let's say 100 is a big number, okay. And so first of all, at the first iteration, what is I? I is 100, which is equals to n, right? This. Then after I became I by C, 100 by 2, so which is 50, right? And on the third time, I will become, I was earlier 100 by 2, right? Also C is 2, so it will be multiply by 2, so it will be 100 by 4. At the next time it will be 100 by 4 into 2. So what is happening right now? So it is n will remain the same for all the time, and then after you have your C to the power k. Every time 2 to the power is always increasing. So here it was 2 to the power 0, here it is 1, 2 to the power 2, right, and 2 to the power 3. So that's how it is increasing till the time it is greater than equals to 1. So it will be n is greater than equals to C to the power k, and when you will be taking the log, it will become log n. So this code snippet and this code snippet is exactly same, the way of writing it is just different. Okay, so third is, you have again a for loop which is running from 0, okay, and to n, and the second is for loop again which is starting from I and it is going till greater than equals to 0. So if you will try to see this, so this first loop is running for n times and this is running for n minus 1 times. So for example, if it is 0, then it is, the inner loop is not running. If it I equals to 1, so it is going only for 1 time. So if it is running for n times, this is running for n minus 1 time. So that's how it is again order of n square. This is the code snippet number 7, where you have a method. Inside this method you have I, j, k equals to 0. Now there is a for loop which is I equals to n by 2 to n, and then there is a for loop which is j equals to 2 to less than equals to n, j equals to 2 into j, okay. So what I'll do, I'll copy this for you to understand here. So this is the code. So if you will observe clearly, so the first loop, let's say n was 100, right, and I is 50, n by 2 is 50, right, n by 2 is 50. So the point is, the first loop is only running n by 2 times. So because I have started this loop from I equals to 50 to 100 it is running, so it is running for n by 2, okay. So the first is order of n by 2. Now I am talking about the second one. So if you will observe this, so starting at start it is j equals to 2, j is less than equals to n, and j is equals to j into 2. First time j is equals to 2, second time j is equals to 2 star 2, third time j is equals to 4 star 2, because now the j has become 4 earlier, right. Then after j will be 8 star 2. So it is again, it's again the power of 2. So 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4. So that's how it is going on, okay. So can I say it is nothing but j to the power k till the time it is less than equals to n, j to the power k less than equals to n, right. If I will take a log, it will nothing but the log of n. We have seen this earlier as well. So the first loop is going for order of n by 2 and the second one is log n. So it will become order of n by 2 log n, which is nothing but n log n. So this will become the complexities of this, okay. And I have one more code snippet for you. If you will see this, there is a first for loop which is going from 1 to n. So and there is one more loop which is going from 1 to till log of I. There are two ways, either you can check first one and second one and multiply it. If the second way, for first loop, for the I is equals to 1, how many times it will go? So it will be like log of 1 times, okay. then for I equals to 2, how many times this for loop will be going on? It will be going on for log 2, and for the third time it will be going on till order of 3, and that's how at the end it will be plus log of n. So what is going on here? For the first loop, okay, I'm trying to calculate for how many times the inner loop is going on with I equals to 1. Okay, it will go on till log 1, right? It will go on till log 2 second time. For the third iteration it will go till log 3. So what is the summation of all this? If you know, there is a property, addition of all logs will be equivalent to log of 1 into 2 into 1 into 2 into 3 into 4 till n, which is nothing but log of n factorial. Okay, and this is equivalent to n log n. Okay, so this is equivalent to n log n. Okay, so that's how the complexity will become order of n log n. If you don't know about this property, you can check out log. Okay, so and if you know, if you are not sure how we have converted from order of n n factorial to n log n, so you can check out the Stirling's formula, which says that whenever you have this order of n factorial, it is equivalent to n log n minus n. So I'm neglecting this, and so the complexity is order of n log n only. So that was about some basic time complexities that I wanted to discuss. Whenever we'll be going into the detail of our data structure, we'll see a lot of time complexities along with the program. Thank you so much for watching.